Uh, okay, so a few days ago, a colleague of mine asked me for something very useful in the context of the vector sets. That is to have some kind of iterator. You have your vector set, you can request with vrand member like all the elements it is composed of, but that's going to stop the server for a long time, and in general you don't want to accumulate millions of items here in your client library, so you need some way in order to iterate. You know, Redis is full of iterators. There are there is a scan that is able to iterate in the key space using a numerical cursor. However, in the case of vector sets, we have an advantage, which is the vector sets are implemented using radix tree view for the dictionary in order to have a map between the element name inside the vector set and the node inside the HNSW data structure, and then there is the HNSW. And the radix tree is very interesting because the keys are ordered in lexicographical order. There is a total order among the keys. So I wanted to implement a command like that, VRANGE, the name of the key, and then the ability to write ranges. For example, minus means the minus possible key, plus means the minus possible element, okay, and then a count. And other than minus and plus, which are special markers, you can specify actually a range, a lexicographical range with start and end, and the start will start with here with the square bracket in order to say inclusive range, or with the round bracket to say not inclusive range. So for example, banana to maximum element, the first 10 will include banana, but with the round bracket will not include banana and will start from the element immediately after. Of course, we can, for example, here as end specify this inclusive, and we will get just the range. This is very powerful way to iterate because it allows to quickly inspect what element is near the other, and there is no state, no numerical cursor. So it's very interesting, and also the algorithmical properties are very good because this is all logarithmic access time. Actually, it's better than that because this is a radix tree. We can consider the access time to be OD1 for the first seek, and then of course other m steps in order to return to yield the m elements. So this is really excellent. However, I wanted to test the implementation of this command to validate this blog post that I wrote a few days ago, coding with LLMs in the summer of 2025, an update, where I see what I say here is that in general it is a good idea to retain control on the code that the LLMs will write, and if you do vibe coding, agentic coding, you lose this control and funny things can happen. So what I did was to start with a prompt. What it is important to note here is how important it is to carefully provide enough context to the LLM, and also useful context. not too much, not too little. You have to develop a skill about how to contextualize your request to the LLM. So what I did was to add the file vset.c, which implements the vector set itself. Note how I refrained from also including hnsw.c. It is true that the implementation of the hnsw, which is the key of the vector set, is inside that file. But for the task at hand, which is accessing the radix tree using the Redis module API, this is useless. So why to flood it? Because vset.c is 2000 lines of code, hns0.c is even more. So this wasn't enough. But this is the prompt that I used. I want to implement a new command called VRANGE. It works similarly to other Redis commands to get lex ranges. Is the exact specification. VRANGE key minimum and maximum count. When min or max are just strings, the lexicographical ranges, but they always start with a special character, round or square bracket, to tell if the interval is exclusive or inclusive, followed by the string. Otherwise, it is possible to specify just minus or plus, that mean the maximum or minimum string. So, for instance, range square bracket foo plus 10 means give me the 10 elements if there are enough. Look at the continuous specification and clues and hints starting with a string. Minus or equal to foo, comparison is just memcopy, so byte to byte, up to any string. This is also a key clue that you will see Gemini ignored. So this was a very big failure mode for Gemini here. The count can be omitted and defaults to -1, which means give me all the elements in the range. The command will use the following API, and I did a cut and paste of the implementation of the Redis API here with dict iterator set start and iterator next, and this is not the prototypes, it's the actual implementation because it's very simple, so I wanted my model to see all it. Okay, we can easily seek based on the user query. However, to stop, I can see any API that allows to use the same operators like minus equal, because what I was telling to the model here is that in order to perform the first seek, we have this powerful API where we can specify like regular expression, I like the first and the last element, or minus greater than, greater or equal than, and so forth. But there is no way as you iterate to say, okay, compare this element with similar operators in order to implement the end. So I specified this to the model. And I want to stop a second in order to show you a peculiar thing. You may wonder how much time you used in order to write this prompt, like 2 minutes, because I never stopped. Like for me, this is a normal process because I do it myself in order before coding something. I can write it down or cannot write it down. More often I write it down. So yeah, but this I can understand that this is a skill that you need to acquire, the ability to communicate the specification that you have in mind. And also every word you stop and say, should I give this clue or not, and so forth. Important additional information. So I told him here, or her, or whatever you want to call the LLM, you have to implement the stop condition yourself. Important additional information. The implementation is required to use the same coding style of the other commands, and there is vset.c as time transfer Example. Minus can be used only as the first argument, plus only as the second, otherwise we get a syntax error. Design a structure so that we can parse the first last argument and get something like that. Struct range op, inclusive, minimum, maximum. So this is in order to avoid that model will spaghetti code the solution without using a bit of refactoring in order to have a function, in order to parse my start and end, and then the logic. Of course, blah blah. So this is the structure, and then it wrote this function parse range op. I already didn't like this particularly because I expected it to initialize the arguments all to 0 and then set to 1 just what was to set to 1. So if it's minus, okay, this is a syntax error if the length is not 1, which is correct, and it sets min to 1, max to 0, inclusive to 1, and so forth. This is the handling of square bracket and round bracket, and I didn't like this because of that. Why to allocate a string if the iterator has all the variants of the API that end with C, that take the C string and length of the string? So we can avoid the allocation here and just use op ele as a pointer. In my suggestion, but this was a bit my fault, I must admit, because I didn't say it char. Anyway, I didn't like that enough, but I must admit that was my fault. Then here it used the idea of using lex compare, doing mem compare, and then helper function, but I don't think that then this function is used. Let me see. Exactly. Did you saw it? It defined this function, which was correct, but then the comparison is done with string compare. Lex compare is lex compare. Never used. What the fuck? Gemini 2.5 Pro, in certain periods, it was used to be super strong and never do something like that. Other periods, when they announced it was JA, it kind of changed. So we developers will need more stability in the models that we use. And instead of just calling something 2.5 Pro, then we'll do a bit more of fine-tuning or a bit more of reinforcement learning, and then I see the same name, but the model is another thing. It's very complicated. I must admit that also these models sometimes are executed with aggressive temperatures on the sampler of the logics of the LLM. So maybe here it was about to write Lex or something. It was like the first scoring token followed by strcompare, but strcompare was chosen just for all. So it's very hard to evaluate a model just from a single prompt gone bad. However, as long as I saw this, not very cool, this not very cool code, I immediately decided to ask the same prompt here to Claude Opus. However, please, not something here. Imagine that I was vibe coding this implementation, and that would kind of work, This string compare here, as long as you never taste things with null terminator in the middle of the string, this is going to work for most of the cases. And you can say, but because you lack tests for this kind of edge cases. Actually, there are just a few tests inside the whole Redis test suite about null terms inside strings, because all Redis is null string safe. It's zero inside strings safe, all the APIs, every part. So there is no point normally about doing that. But you see that here it's different because the LLM picked the wrong thing. So how important it is the human in the loop. Another thing, if you see it is good enough code here, it is mostly because with my prompt, I was the architect here, I was the designer. Otherwise, I strongly doubt, and I tested other times, that would be the implementation that it would produce. Actually, we could test it too, but for now, let's continue with what Claude did. So, okay, I just copy and paste the same prompt that I gave to Gemini in order to be this a completely fair comparison. Okay, this is what he did. This is very similar. This time there is the initialization here, and then it will only touch what's needed. Also note here that it's more sane to don't care about inclusive. Once you specify minimum or maximum, those are special tokens, so it's not needed. Everything is more clear here. However, it also creates the string, but we saw that this was my fault. Also here, compare strings is much better because and it's not about once you created everything with Redis module string objects, then why to go for this solution here of having char length? Stick to your API. So this is better code that Claude Opus wrote. By the way, I have just the pro plan, the $20 for month plan, which is enough for me because I use the web interface and I don't burn millions of tokens using Claude Code. So also it's a very different economy of tokens, of energy, of everything. Let's check the implementation. Argument checking, count. Okay. This is the specific check in order to see if parse count if provided. This count written small, I don't like it. Better to capitalize it. Parse range operators, which is legit. Validate minus can be only the first plus only the second, which is fine. Open key. The empty key produces an empty array, which is the correct behavior. Redis module style get. Here there is the cleanup needed because we allocate this string. You see, this also forces us to handle the cleanup. Okay, we get the Vuset object and then we perform the seek and so forth. Later we will check better the code quality. This is the main loop. So what's happening here is that we iterate with next dict next key with my key and key data. This is correct. And oh my god, that's terrible. Every time a string is created here. This was also like that. No. Current key. It used the iterator ability to create. So basically, yes, it's allocating again and again. And these two. Also, what I didn't like here is this generic, but in this specific case, two generic string comparison function. Just let me check one thing. But this implementation here, does it produce an object, a new object that must be freed? Yes, create string. It's in the context source will be reclaimed, but here we are allocating way too much because it's not freed at every iteration. You see how many problems. Here the memory is correctly handled, at least, because it's create and then compared and then also what I didn't like is that yes, this generic comparison function here, you see you have this strange condition which is not terrible, but let's see what I said. Not bad, thanks. Rewrite it with the following changes. The structure where you parse the operator will have unsigned char L and size T LLN. This way we don't need allocation. Instead of a generic compare string function, write a vset is element in range where you just pass the current string element and the second operator end. So we just check, have a specialized function with the logic inside that just tell us you arrived to the end. Sorry, my fucking phone. This makes the command simpler to understand and the check logic will be isolated in the function parse range op, vset parse range op, all the comment sentences end with a dot. And it was rewritten. Look at this. Vset is element in range. It's just a memory compare, and if the comparison is 0, the length wins, the longest wins, and then basically we return 0 or 1, and this depends on the inclusiveness of our ending end string. And once we did this change, to start, we no longer allocate anything. We just get returned the key data and key len. However, let me check. Yeah, it's internal to the iterator, so it's allocationless. That's handled by rax.c raxne start stack init blah 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 key static string. Okay, yeah, very efficient. At this point, let's look for the end check, how clean it became. If not, vset is element in range, break. That's much better. This is a better implementation. But because the human was in the loop. And okay, now it's telling me how cool it is. The new implementation. Yeah, but I told you. So fly down. There is no need to access the HNSW node to return the element. The iterator is already returning the key. Look at what it did here. HNSW node data. And Okay, here this is the accessory value stored in the radix tree node, but it's absolutely not needed. We already have a pointer to the key and the length of the key. Why to go to inside the HNSW node and take the element? Completely useless. Okay, another implementation. And it's even better. Look at this while loop here. Redis module reply with the string buffer key data key len. Okay, you know this is quite obvious for an expert programmer, but still the LLM struggles a lot. So finally I copied hit here. VRANGE. VRANGE. Yes, it looks error count must be. Nah, that's, for example, let's fix this a bit. Directly here. Let's check here when how the count is checked. If count is equal not equal, I will say if count is greater or equal to 0 and we reached our count break. So here we just generalize this to any negative value. Basically will produce an infinite stream of elements instead of this specific value of music, because I cannot think at any way to use in the future in VRANGE a negative count. So just any values less than 0 will produce an infinite amount of elements. Okay, so we just check that yes. Then there is the parsing. Then there is the validation. Exactly. This is a nicer way in order to check that minus can be just the first, maximum can be just the last. Open the key, start the iterate, or okay, I will do a full code review because here would be too boring. Just at this point, yeah, I already shown you how do you iterate. For example, let's check with this key here, this here, VRANGE, this key minus plus 10. Then you take your last element here, and you just do that. Unfortunately, there is to escape this in some way. Brienne. I want to be sure that this is correct. Minus plus 20. Yes, after Brienne there is also this Connor, and so this was correct. And then we already take the last one, and we can iterate everything like this. We will receive all the elements. This is extremely useful. Okay, so when the human is in the loop, it informs the design. When the human is in the loop, it checks if the code is correct, will fix it as needed. I will now perform a full code reviews of this code. it was faster or slower than coding it myself. In this case, probably it was a lot more time consuming, but I wanted to make this video because it was very simple, but for more complicated implementations, to have just the first implementation that already respects your design and then hack inside it could be an interesting way to proceed. There is also a psychological factor that must be taken into account. Sometimes you just are tired. It happens that in certain days you are tired, and this is a way that you can get you started. For example, you slept 3 hours because your small child cried all the night, and so this is a way. Then you like how things are coming out, and you start coding, but it's like your body that will push you forward a little bit. Okay, I hope that you liked this video. Thank you. So you will see VRANGE very often inside the Redis code base. I will review it carefully. I will see if I want to extend this also to have the arguments swapped and return the range backward. It is possible that I will do that. I still don't know, but I will open the pull request in the next days, and it will be merged. I'm not sure if it will be backported, but we will see it soon. Bye.